Dear students, if you want to calculate the protein structure, then you need to know which types of bonds exist within the protein structure and how many are they in number. This is because the greater the number of bonds, the lesser will be the free energy, or in other words, the number of bonds is inversely proportional to the energy of a protein. So if the energy of the protein is low, it becomes a stable protein. So how can we go about calculating the energy of a folded protein? If you look at this table, you see van der Waals forces, hydrogen bonds, ionic interactions, and hydrophobic interactions, their strengths, and the distance that they lead to between the atoms of the participating bond. You know that there are these 4 types of interactions that may exist along the backbone of a protein, and that the strength for van der Waals interactions is simply between 0.4 to 4 kilojoules per mole, and the resulting bond distance is between 0.3 and 0.6 nanometers. For the hydrogen bonds, the strength is between 12 and 30 kilojoules per mole, and the distance between the participating atoms is about 0.3 nanometers. So if you look at this information, and if I give you a structure that you can measure and you can look at the lengths of the bonds in the structure, then 1, you can tell me the minimum energy of the protein, and 2, the number of bonds in the protein. Okay, so you know that the most powerful interaction within the protein is therefore the hydrophobic interaction, followed by the electrostatic interactions, followed by the hydrogen bonds, and then in the end the van der Waals forces. So you would obviously want to maximize the hydrophobic interaction or the electrostatic or ionic interaction. At the end, you can sum up all of these interactions and compute the energy of the protein. So given the number of atomic interactions in a protein, you can simply sum the energy according to the number of the bonds and arrive at a number that depicts the stability of your protein. As you just saw the table, I have formatted it into an equation for you for better understanding. So if you want to look at the total energy in a protein, you simply look at the number of atoms that are the pairs of atoms that are involved in the van der Waals forces interactions and the energy for such a van der Waals interaction, which is given here. And then you look at the atom pairs that are making hydrogen bonds, and you can look at the energy that is released as a result of formation of a hydrogen bond given here, and the same for the ionic interactions. So you look at the couple of atoms that are interacting ionically and you multiply them by the energy of the ionic interactions, and you take a sum over this entire interaction. So this will help you to arrive at the total energy for the protein. So in conclusion, the energy of a protein can be very easily calculated by multiplying the number of bonds or interactions of each type by the corresponding energy that is released as a result of this interaction, and you sum all of such interactions within the protein and you arrive at a number. Obviously, you can have a case where you have 2 different folding values for the same protein, and then you can select the one that is lower in the magnitude. And then accumulating this energy and the interactions can help you to estimate the best possible structure for a protein.